Somebody tell me what shape do we have?
Square.
Square. What do we know about a square?
All sides are even.
Good. You're writing this on the back of that paper, right? So we know that all sides are equal. What else do we know?
Four right angles.
Good. We have 4 right angles.
Two isosceles.
What did you say? We have 2 isosceles. What does isosceles mean?
2 sides.
2 sides, and it's a right triangle also, right? Okay, so it's important to recognize that this triangle right here has 2 sides that are equal, and it has a right angle. That's important, because I could just tell you from now on, if you have an isosceles right triangle, there's going to be a lot of things that you already know. Okay, what else do you know about this isosceles right triangle? Good, it is a 45, 90 triangle. It has to be, because the diagonal of a square cuts it into 2 equal parts, right? Okay, so that's extremely important. Okay, now flip your paper over. Yesterday, I asked you, I think, after your quiz, to work these 4 up top. Did we have a chance to do that yesterday?
Yeah.
Did anybody not? Okay, so if I work the first problem using Pythagorean theorem, what's Pythagorean theorem?
A squared plus b squared equals c squared.
Very good. Now, I've asked you to stop using decimals, correct?
Yes.
Okay, and some of you don't like that very much because on your quiz you had a lot of decimals, right?
Yes.
Okay. When you go to Chuck E. Cheese, can you just take your money and put it in the machine and everything's good?
No.
No. Why? Because you have to get the Chuck E. Cheese tokens, don't you?
Yep.
And then you use those tokens when you go to another country. Okay, which has kind of changed a little bit now. But for the most part, you can't use our money in another country. You have to switch it out, don't you?
Yep.
Okay, same thing here. Sometimes you have to leave it in a certain format because that's the way you're going to see the pattern. If you changed all of these answers to decimals, you would not see the pattern. Are you with me? So there's a purpose for it. And I've tried to start the process of you figuring out how to understand how to work some of these problems. Because really what I'm about to show you is a shortcut. And I'm going to tell you on these problems you will no longer have to work Pythagorean theorem. Is that awesome? You'll look at them and you'll know the answer right away. You'll be able to put the answer up there and move on. So when you have your time test for the SAT and you run across this kind of problem, you can save time not spending it working Pythagorean theorem. Does that make sense to you? Okay. So right here, if I did Pythagorean theorem, it's 1 squared plus 1 squared equals c squared. 1 times 1 is 1 plus 1 is c squared then, right? 1 plus 1 is 2. Then I would take the square root. So that means my answer for this side right here is the square root of 2. Everybody get that? Is that what you got? Yes? Okay, so for the next one, we would do 2 squared plus 2 squared equals c squared, which would be 4 plus 4 equals c squared, which is 8 equals c squared. So then I take the square root. Remember, I don't want decimals. But can I break this 8 down to what?
2 and 4.
2 and 4. Can I break the 4 down?
2 and 2.
2 and 2. So I have a pair of 2s. What happens with my pair?
Come outside the house.
I guess to come outside. And what do I leave with the one that doesn't have a pair?
Leave it inside.
I leave it inside the house. Huh. Look at that. Okay, so on the next one, 3 squared plus 3 squared equals c squared. 9 plus 9 equals c squared. 18 equals c squared. Take the square root. How can I break 18 down? 9 and 2. Can I break the 9 down? 3 and 3. Do I have a pair? What happens to my pair? It's to come outside. Who has to stay inside? Are you starting to feel a little better with some of this?
Yep.
Okay. And then my last one right here. We have 4 squared plus 4 squared equals c squared. 16 plus 16 equals c squared. That would give me 32 is equal to c squared. Take the square root. How can I break 32 down? 4 and 8. 2 and 16. Either way is fine. 4 is broken down to 2 and 2. 8 is 2 and 4. 4 is 2 and 2. So I have a pair of 2's here, and I have a pair of 2's here. I have 2 pairs. What happens to those 2 pairs?
Multiply.
You multiply. So 2 times 2 is
4.
4. And is there anything that has to stay in the house?
2.
Okay. Somebody tell me by looking at my answers, what do you notice?
Whatever numbers it's
Hold on, you guys. Go ahead.
Well, the numbers on the outside that you start with, I guess that would be on the outside of the house, and then the 2 on the inside. That's good.
Okay, so I think what you just said is this number right here, because there's no number, right?
Yeah.
If I just told you x, wouldn't it be 1x?
Yeah.
So here there's no number in front, so it's a 1?
Yeah.
Where'd they get the 1 from?
There. Yeah.
Where'd they get the 2 from?
The side.
Where'd they get the 3 from? Where'd they get the 4 from?
The leg.
And what do each of them have? Are you with me? Do you see that pattern? If you would have just put decimals, you never would have seen that, would you? Okay, so let me ask a question. I'm playing pretend. What if we had a triangle that was an isosceles right triangle, which means that these angles are 45 and 45, correct? And I told you this side was 56. How big is this side?
56.
And if you're guessing, what do you think this side right here would be? Based on this pattern. 56 square roots of
2.
always. If I had a triangle, and it was an isosceles right triangle, which means this is a 45, 45, 90 triangle. And I told you that this side was 123. How big is this side?
123.
And how big would this side right here be?
Square root of 2.
123 square roots of 2. Always. There's no need to do Pythagorean theorem. Can you do Pythagorean theorem?
Yep.
Absolutely. Okay. Now, so let me tell you what I just said. I'm going to condense it down just for a second for you. What I told you is if I'm given a 45, 45, 90 triangle, if these two angles are congruent, then these two sides are the same. Right? There's a pattern. This side is x. That means that this side would be x because they're both the same. And whatever this side is, the hypotenuse side is going to be x with a square root of 2. Now I'm going to lay a word of caution on you for a second. Because I can have 4 quarters and a dollar. Does the dollar have quarters value inside of it? So the quarters are hiding inside of a dollar bill. Would you agree? Sometimes on these problems, that square root is hiding inside of another number. And I'm going to work one of those problems here in a second. I don't want you to think that this side will always have a square root of 2. That pattern always works. But it doesn't mean that there's always going to be a square root there. Okay? Second thing I need you to understand. Okay, everybody look at this middle problem here. They have an x and a y. Did we talk about an x and a y in our pattern? Because this x right here and this y right here are not the pattern. That's just a way for me to say, hey, I want to know how big this side is. Or, hey, I want to know how big this side is. It has nothing to do with the pattern. Are we okay? It's kind of like numbering a problem, problem number 1, problem number 2, problem number 3. I just have to communicate to you what side do I want. Are we good? When you're working these problems, okay, when you're working these problems, I would tell you every time, okay, every single time I would encourage you to put the pattern there. So on this one right here, this angle is 45. How big is this angle right here?
45.
That means that these two sides are the same, correct? So my pattern would be x, x, what goes up here? X radical 2. That's my pattern every time. Now what I know is that x is equal to 10, isn't it? So how big is this side? 10. So how big would this side be? 10 square roots of 2. Are we okay? All right, so let's take a look again. What about this one? Well, that looks a little ugly. But here I know that this angle is 45. How big is this angle? Doesn't that mean that these two sides are the same?
Yeah.
So think about the pattern. Think about the pattern. What could I call this side? X. What would I call this side? X. And what would I call this side?
X radical 2.
X square root of 2. This one already has the information, doesn't it? So the square root of 2 is already there, so how big is X?
7.
So this side is 7 and this side is 7. Are we okay with that? Alright. Now I need you to really put on your focus brain for just a couple of seconds. Is that okay? Because on this one right here, it's the same kind of problem, but it looks differently, doesn't it? Because this is 90 degrees and it tells me that these two are the same because they're both X. How big are the angles? 45 and 45. Okay, if I were going to write the pattern, what would I call this side right here?
X.
What would I call this side?
X.
What would I call this side?
X radical 2.
Oh, but wait a minute, Miss Ramsey, there's no radical 2 there. That's because it's hiding. Okay? What that means is, on this side, the pattern is x squared root of 2, and the answer is 18. So x squared root of 2 is equal to 18. Side note real quick. If I told you 5x is equal to 10, what would you do? Divide by 5, right? And the 5's cancel out? Same thing right here. This is x times something, and you would divide. So here I'm going to divide by a square root of 2 on both sides. That means this cancels out. Does that now look like what you just did on your quiz?
Yep.
So what would I do with that to solve it?
Multiplies radical 2.
Everybody with me? So on the top, it would give me 18 square root of 2. And on the bottom, I have a pair. When I have a pair, what happens?
Comes outside the house.
It comes outside. Does 2 go into 18?
Yes.
How many times?
9.
Hold on. That means this side right here is 9 square root of 2. Hold on, watching. This side right here is 9 square root of 2. And if this is x squared root of 2, my x is 9 square root of 2 with a square root of 2. 9 square root of 2, I'm sorry, square root of 2.
That 2 comes outside.
That gets to come outside. What's 9 times 2?
18.
So was the pattern still there?
Yes.
Yes.